Alright, so we're going to do arithmetic. We're just going to do very simple adding. First thing we want to do is basically just throw everything away that we've done before. I'll just do that here. We can basically throw everything away. Yeah. I will leave the readme or delete it as well. Then we'll start a new file for our code that we are writing in our own language. So in my case, that's app.boo. The file extension is boo there, and it's going to be adding 1 plus 1. So the expected outcome from running this program would of course be 2. This is all we're going to write in our source code for our own program. We're going to keep it real simple. Let's start with our main entry point, so boogie.py. Of course you can call it whatever you want. I've already written this code, it's on GitHub now, so I'm going to copy it basically from here while trying to explain it. We need to import a couple of packages, and then we will do that later. Then I will start a class called boogie, and I will create an initialize function, a constructor, which will take a file name, and that will be the file name of our source code that we just wrote. That will need to convert that into a program, which we will do by something called a bootloader. Learning from my past mistakes, I will prefix everything with our sort of abbreviated project name, so nobody's going to get the parser error that we had last time. File name is going to be passed to the bootloader. And then let's create a main function as an entry point for our program, which gets also past the file name, and then it just goes calls that class with the file name, so that it is going into the init function here and then passed to the bootloader, which will then return a program, which we actually don't do anything with, but leave it for now. So then this sort of weird magical thing Python has to create an entry point. I don't necessarily understand it, but okay. Let's do a try, and then call our main with the command line argument coming right after the file name that we're executing. So that's we will be executing something like python.boogie.py, and we want to pass in our source code, and that will be in argv1. So then let's catch an exception. Actually, let's accept, isn't it? And then we can fatally log if we don't have a file name. So no input file provided. Okay. We cannot run this code yet because let me also split the screen so I know that I'm not going too far to the right, and you cannot read anymore. Right, so now we need to create that bootloader. So let's create a new file called bootloader.py, and let me go to my reference. So now bootloader wants a class, or is a class, which has an initialize function, our constructor, which has self and has the file handle that we passed in from our main function. So then what it will do is it will create a program by doing program, and it will actually open the file now for reading only, and then it will say program.run. Actually, I said I was going to use small letters. So now we create that program class and say okay. In our init function, we pass in self and the file handler. Actually, this was the file handler, this was the file name. Let me try to do things correctly. Oops. And then we will have the code be the file handler. So this is now the actual contents of the file, self.code. We will then define our run function, which will have self. And what this will do is loop over every line in our code. So now we're going line by line. Obviously we only have the one line, but that's fine. So to make it easy, let's print formatted the line here, so we have something we can look at for debugging. And now we need to create our lexer. The way that it's going to work is it's going to be called boolexer. It takes no arguments, and then it will say lexer.run in small letters on the line, and then eventually it will give us back. Let's format that string. It will give us back tokens as a list, which we can inspect by saying lexer.tokens. So that lexer is going to be loaded in here. So we say from boolexer import boolexer. Alright, so let's write that file and then create a new file called boolexer.py. Now, this is going to do the bulk of the work of doing the first round of structuring of our code to be eventually evaluated by our evaluator. So what we need here is to import the enum class from the enum package. What that will allow us to do is define something called lex_state, which will then inherit from enum, and that will allow us to define sort of like the states of a state machine. So we can have init for a starting state, delimiter, numeric will be 3, and operator will be 4. These are the states we will need right now. We don't even use all of them, but use class boolexer now. We're gonna do our actual lexing. So define the init function, pass itself. It took no arguments. It will have a state, which will start off with the next state of init. And this is what the enum will allow you to do. It basically maps, in this case, integers to a more human readable format. And then it will have a buffer to be explained later, but it's a list. And it will have tokens, which is the thing it will return. So then we had a run function. It takes self and the line of code that was being looped over in the previous file. Now we're gonna loop over every character in that line. So now from that one line we're going to loop over each character individually, and for debugging purposes we will actually print that formatted as character. Now we will have a method called self.getState, which will take the character, and then we'll have a method called self.handle the state, which will take no arguments. So let's create self_state. It takes self and character we set. Well, that's get state. We can actually do some printing again and use Lexer.get state. So here I'm just printing out the sort of a representation of the function that I'm using, and then I will print the actual state that we are in. This is just really good for debugging. You will see it once we run it. Then self state and self buffer will be filled from boo state, which will take self state, self buffer, and the current character, and then call for the next state. This maybe seems like a bit of a lot, but let's just define boo state now, and then it will most likely make more sense. So let's define that class. Actually don't need to do that. Create a constructor, pass self, state, buffer, and character. Those were the things that we passed in that longer statement we just wrote. So we set the local state to state. We set the local buffer to buffer, and we set the local current character to the current character. And then we need a couple of more things. Self delimiters. This is kind of like a lookup table, which will also make more sense soon. For now, the delimiters that we want to look for are colon and space. We actually don't really use them right now, but that's sort of left over from the previous version of this code base. So we also have a couple of operators we're going to define, just plus and minus for now. Although we will only implement adding in this video, we'll do the rest in the next one. Let me just clean up. Alright, and then define that next state method. Alright, so first thing this will do is to the buffer, it will append the current character. So now we're building up a small buffer of growing characters. Now we say if self.character is in the self delimiters, then what we can do is return a new lex state, which is the limiter, and self the buffer. So basically that's what's going to fill these two variables here. We set self state comma self buffer, so we're filling up two variables from the same return out of a function. We fill up those two variables with the new state and the new buffer, which we are defining over here. Let's write the rest of this as well. So if self character is in self operators, then we can return a lex state of operator and also self the buffer. And then finally, if is numeric. So this basically looks at the character and looks at, hey, can I parse this into a number? If so, then what we want to do is return a lex state called numeric, and return also the new buffer. And then finally, if none of these things are true, then we just return the state and the buffer. So this leaves the state unchanged, and the buffer will have appended to it whatever was the current character. So we can continue building up, like for instance if we're looking for a keyword or something. then we need to add one more method to this, but we can do that later. Now that we have that, we want to implement handle state. Oops. So, handle state will take self and the, what is it? It will only take self. So we can print again, formatted buffer. We want to look at the buffer as well, because that's useful. We can actually do that like this. So that is self.buffer, just so we can see it grow. And also we want to do, in this case, another print, formatted handle state, and we want to print out the state so we can see how it changed. Now we can append a token, because we know now, actually we're going to do that later, but yeah. Let me just write this out, and then we will work through it. Yeah. We don't have to pass the character in here, and then finally we want to call state token as a method. So here we are appending to our tokens from boostate, which we initialize again with state, with the buffer, in this case joined though, and with no current character, because we don't need that. So now we set we want the state token, obviously against self. And then this is actually quite simple. We can just return a dictionary with an ID that is called self.state, and a value that is called self.buffer. So now we will have a token that is the state as a key and the current buffer as the value. Okay, let's save that. And then we can go back to Bootloader. We've now basically done the lexing, and I think we could actually print that out. So let's have a look if we can. So okay, lexer is not defined. This is where the trouble starts. Not here. Not here. I need to look at the error again. It said lexer gets state. Ah, okay. So it's actually in the boo lexer. Ah, I see. And also over here. Yeah. So we can see now how over here, indeed, the line is being printed 1 + 1. That's our code. Then it goes for the first character. It says get state. My current passing in the current state, which is in it. It looks at the buffer, which is now 1, as a string, and then it says handle state, lex state numeric, because that was returned by get state, and it will then clear the buffer, and it will continue doing this. The plus will be an operator as a chippy. You just get those delimiters thrown in, and then another numeric R1. So that means that we can see here that our tokens being printed indeed, like our first is a numeric, value 1, then a delimiter. Oh, these values shouldn't be in here, but we can actually forget about that, we don't care. Although something is going wrong, I think we're not clearing something, so let's take a look. This is totally true. We forgot to say here self.state equals let's.state.init. It should go back, and then self.buffer is empty again, because here we've processed our token, so we should get ready for creating a new one. Now when we run it, we see a numeric, value 1, a delimiter, value space, which is the delimiter, an operator of value plus, and it continues on like that. So now we can actually go back to Bootloader. We are going for the next step, which is the parser. So let's just first write it into the Bootloader, and then we will implement it. So we will say from boo parser import boo parser. Okay. Then down here at the end we will say, okay, we need to instantiate a new boo parser. In this case we want to pass in the tokens, and then we say parser.run, and then we can actually print the AST. Parser.ast. So the abstract syntax tree will be the second abstraction of our source code. So the lexer is the first abstraction, it converts into tokens, and now the abstract syntax tree is going to be an abstraction that shows how to execute the flow of that program. So we've done all of our work here. Hopefully everything went okay. And let's create a new file, call it booparser.py, and implement it. It should be relatively simple. First of all, we need something from boolexer. So we say from boolexer import lex state. I want that state definition back here, because you will see why. Booparser has an init function. We said we're passing the tokens, so make sure we accept those, and then set the local tokens to tokens, and the AST can be initialized as a list dictionary, and then we need a current key. It's a bit of a hack, but we're going to use it. And then I want to have some memory, which I will need later, and you will see why. This is all still most likely not the right way to do things, but I'm kind of running with it. So first of all, we're going to loop over all of our tokens that we are getting in. Now, if the token ID equals the lex state of numeric, we want to do something called store memory and give it the token value. So we're going to we saw that our incoming token was a numeric token. It has a value of 1, we know that, and now we want to keep track of that. So the way that we do it is by implementing that store memory function or method, which accepted the value, and then it will say self memory.append the value. Okay, it's done that. Now, if the length of the memory is bigger than 0 and self-current key is not none. At the moment it's none because we've initialized it over here, but if it's not none, what I want to do is dump the memory. Yes. Okay. And dump memory, we can already implement it. Why not? So let's implement dump memory. I think it only takes self. Yeah. Now, what that does is it goes to the AST, looks for the current key. So it looks for the branch with the current key, and then adds memory to it. Like everything that is in memory, think of the AST as, well, you will see it soon, but it's a key value store. So we have a AST. It has a current key that is currently active. We're currently working on that branch, that key. And now we want to add a value to that key. That's what we're doing here. We're just dumping memory into the value of that key in the AST, in the abstract syntax tree. So then we can clear out our memory, because we've now used it. And we can also clear out our current key, so that it's ready to be evaluated again. Alright, so now that we've done that, if actually that's done, right? Yeah. I hope I'm in the right indentation. If the token ID is let's state dot operator, we want to have an add node token value. So this will add a node to our abstract syntax tree with the key. Yes, with the value of our token as the key. That makes sense, because that is now at the moment the plus symbol as a string. We have to hack around there at some point, but you will see how that works. So add node is a very simple function at the moment. That will definitely grow a little bit more complex, but basically we say initialize a new key that was passed in, and then keep track of that in current key, because we needed that over here to be able to dump memory into that position in our abstract syntax tree. Okay, now that we have that, we can actually probably run it again, right? Wow, that worked in one go. So our tokens, that's where we left off last time, are over here. Our AST is now over here, and you can see how that here is a dictionary. It has the plus as the key, and as the value, it has an array of 2 strings of 1, which is what we had over here, 1 plus 1. So it restructured 1 plus 1 into basically plus 1, 1, basically into Polish notation, which is way easier to do with, because now we can do something quite simple. Let's go back to our bootloader and implement what is basically the final step in this version. Evaluator. We're going to call that booeval. It takes the AST, and evaluator will then run. And then it will eventually have something to say to us, which we will call the output of our program, basically. Evaluator.output. Now we have to, of course, import that package from booeval. Import booeval. Let's write that. Okay, and then create a new file called booeval.py. let me split the screen, so I'm for sure not going to be too far to the side. Boo eval.I, we said. Okay. And this is going to be actually really simple at the moment. So it's a class, boo eval, has in its function, like most classes do, self and AST. This is what we're passing in. Then let's set the local AST to AST. Set initialize output as a string. And this is the hack that I spoke of a little earlier. Because I didn't deal with the plus sign in my lecture, which I probably should, the trick I'm going to do needs some work, because I cannot define a method. This is something I could do in Ruby. In Ruby I can do def plus. Yeah, and then obviously it's Ruby because end, so end. And this method will actually be, like, I will just override the plus method basically. Like this works. In Python I cannot do that. I cannot do, I tried it. Unfortunately, it's a syntax error. So we need an add method. Let's do that first actually. Let's write our add method that we're going to map to, so basically all that does is it writes output and it sums the values that we have. Our AST has this plus key, two values as a list of strings. So those are the values that we're going to pass into this method add, but we need to map them to ints first, otherwise we can't add them obviously. So the only thing we have to do is our run function then, which just takes self, and what that does is it loops over the nodes in the AST. Then we have to do a little trick here for the hack. So if node in self dot operators, then we say n self dot operators node. Otherwise we'll just leave it like it is, and then comes the thing that I'm very happy that I discovered. If you can do a little bit of meta programming in Python as well, and we are going to do that like this. So when we go self for node in self AST, yeah. We have only one node in our AST, so that node here at the moment node equals plus. So that's what's going what's coming in here. So when I say n equals node, now n equals plus as a string. Then I say when node is in operators, so in this case when it's plus, it's in the operator operators. Then I want to replace plus with the word add, because I need that. Because here what I'm basically doing is I'm asking the class itself, like, hey, do you have an attribute called n? And in this case n is the string add. So now it's going to look like, hey, do I respond to a message add? And a message, like a method, the way you call it is basically by sending a message to an object. Our object is booEval, our message is add. So with a get attribute, I can say like, okay, give me that attribute of yours. And then by putting these brackets here again, it basically executes that method. And I can pass in self AST node my list of values. And that's what's going to be mapped to here. Oops, again. And I think that's all we basically need. Oops. To make this work. No, booEval is not the line. Okay, so made a mistake. That's probably in Bootloader. Yeah. Let's just rewrite that. Should be fine. And exactly. Now we left off with the AST over here, plus 1, 1, and now it says output is 2. And it should be that if I now do add dot boo, if I change my actual source code to, for instance, I don't know, 12 plus 1100. Run it. That's interesting. We made a big mistake here. And we're gonna solve that in the next video.